Chapter 5, problem number 18. A block is hung by a string from the inside roof of a van. When the van goes straight ahead at a speed of 28 meters per second, the block hangs vertically down. But when the van maintains the same speed around an unbanked curve of radius 150 meters, the block swings toward the outside of the curve. Then the string makes an angle theta with the vertical. Find theta. Okay, so we know the speed and we know the radius. And they want us to find this angle here. So if we break the tension up into its x and y parts, you can see that Tx provides a necessary centripetal force, so we can set that equal to mv squared over r, where v is 2 pi r over the period. Actually, we don't need to do that because we know v and we know r. But t, in terms of the angle, is t times the sine of theta. So we have t sine theta is equal to mv squared over r. Right, so if you take the sine of this angle, okay, which is here, and you multiply it by t, the tension in the string, you will get Tx, the x part of the tension, okay, right there. Now, we know from Newton's second law that since the acceleration is 0 vertically, that Ty is equal to the weight, where Ty is t cosine theta and the weight is equal to mg. So solving this expression for t and then substituting it into there, putting that into there, we get mg tangent of theta equals mv squared over r. So the masses cancel. And then solving for theta, we get the arctan of v squared over rg. Let's do the numbers. V is 28 meters per second. Square that, divided by r, 150 meters, multiplied by g, 10 meters per second squared. So we're taking the arctan of v squared over rg. And I'm getting about 27.6 degrees.